Hey everyone, in this video I'm going to be doing a cool demonstration called the blue bottle. And what it does is it shows a interesting property of a chemical called methylene blue, and that is it's a redox indicator. And that means that the structure of methylene blue, and therefore the color of it, changes based on whether or not it's in an oxidizing environment or a reducing environment. So to do this you need to make up a reducing solution. I've done that by dissolving some sodium hydroxide in water, concentrated, but it's pretty close, and then I'm going to be adding some glucose. Now you might be thinking, okay, I'll just add the sodium hydroxide and the glucose together dry and then add water. Don't. I tried doing that, and as soon as I started adding the water, the sodium hydroxide and the glucose started to react really violently, and I was not expecting that. It turned black and bubbled, it got really hot, and I had to dilute it with a lot of water to prevent the reaction from getting really out of hand. So found that doing it this way is the best. I tried for a while also to find some over-the-counter glucose to do this with, and with not much luck, I used a Splenda packet, and that worked one time. And then I tried to buy Splenda, but the Splenda that I bought was maltodextrin, and the Splenda packet was glucose, so it only worked with that specific packet. Anyway, so I just bought some, and well, that'll work. Okay, now that you've got them dissolved, I'm going to go ahead and grab the methylene blue and get back to you when I've done that. Here's my sample of methylene blue. I was really lucky to find this in an old chemistry set, so that's what I've got. Anyone who's worked with methylene blue can tell you that it does not take much to get the job done. It will stain just about everything, so be really careful when working with it. You don't want to get it on anything. So to add it, I'm just going to be using this X-Acto knife and taking up, if I can get a really small crystal, or flake, or a few flakes. Okay, I've got a few flakes on the end of the knife there, and I'll add them in. And you should be able to see it start to dissolve in there, kind of fall into the solution. I might have to agitate it a little bit. Yeah, there it goes. And you can see the blue color, so there's still some bigger pieces there. So, get that all dissolved. Alright, I'll get back to you once it's all dissolved. Okay, now I shook up the solution with the methylene blue to get it all dissolved, and there's still some chunks kind of swirling around and dissolving in there, but you can see the blue color of the methylene blue. Now you have to do this with a container that can be sealed to prevent air from coming in. And here's the reaction. When I shake it, air or oxygen from the air gets in and makes it an oxidizing environment, therefore it's blue. Now, when no air is introduced, the glucose and sodium hydroxide make a reducing environment, which causes methylene blue, a reducing indicator, to turn to the colorless species. And that's what we see here. The solution goes clear. Now you can still see a chunk of methylene blue dissolving at the bottom, but it fades from that blue to a purple to clear. The cool part about this is it's repeatable. We're back to the blue color. Now the higher concentration of sodium hydroxide and glucose you have, the faster this should happen. And there it goes to purple. It's kind of sudden. And looks a little purple on camera, but it's pretty clear in person. I might have added a bit too much methylene blue, so that's what's responsible for the slight purple tinge. But it looks pretty much clear in person. Alright, I hope you've enjoyed this demonstration. Thanks for watching. Please send me a message or post a comment if you have any questions, and I'll be happy to get back to you.